What's something you can get when you can combine PCG and geometry scripting? Well, you can get a tunnel, a full tunnel system. And not only is it a full tunnel system, it can be a full cave system with large caves, stalagmites, stalactites, rocks on the bottom, whatever you'd like, fully customizable. And not only that, if I zoom out, it is just controlled with splines. And so what I can do very easily is just duplicate a spline and move it around and then regenerate the graph. And I will get this, a full new path with a full entrance here. It goes all the way up, following the path that we created, however we'd like. And in the end, you're left with a simple piece of geo that you can sample and control as you wish. So let me show you how to set all of this up. To get started, we need to enable some plugins. So go to Edit, Plugins, search PCG, and make sure you have PCG turned on, as well as the geometry script Interop, and restart your engine as needed. From here, we'll need two things, being our PCG graph that we're going to be using. We're going to use a create empty graph, and this is going to be our PCG _ tunnel system. And we're also going to need the tunnels themselves, which are going to be splines. I'm going to right click, go to blueprint class, grab ourselves actor class, and we're going to call it BP _ tunnel. Let's open up the BP tunnel. And in here, all it is just going to be a simple spline. Just add a spline component. I'm just going to move it outwards so it's a bit further out. Makes it easier by default. At this point, let's go ahead and drag out the PCG graph. I'll go ahead and remove the floor here, and I'll drag out the tunnel as well. So here we have the tunnel spline, and we'll go ahead and even customize it just so we have something here as a good example of what's to come. And with that, let's go ahead and open the PCG graph. So the way this tunnel system is created is basically by using dynamic meshes, which is geometry scripting inside of PCG, to convert some meshes into a tunnel, weld them all together, and then you're left with one nice mesh that you can then sample. And the way we create the tunnel system is by just spawning spheres. Seems like a very simple way of doing it for me. I'm just going to spawn spheres along the spline. They'll also automatically scale with the spline points so you can control bigger and smaller areas. So let's do that. For the cave system, we're of course going to need to know the locations of the splines. I'm going to right click and search for get spline data. Now the spline data is not on itself, so we're going to change the actor filter to all world actors. Instead of by tag, we're going to go by class. And in the actor selector class, you want to plug in your BP tunnel that you created, or whatever you called it. I'm also going to make sure select multiple is turned on. And if you're going to have multiple of these systems, you might want to do must overlap self. From here, though, we're just going to use a spline sampler and sample the splines. We're basically going to spawn spheres along the spline to make up the actual tunnel shape that we're then going to kind of combine and convert into the interior walls. So in the spline sampler, instead of subdivision, we're going to go by distance. I'm going to change the distance increment to be something like 50, so it'll be relatively close together. From here, I'm just going to use a merge points node because I want to make sure that all of the spline data that we got, if there's multiple splines, which we can get really easily by grabbing our tunnel and just duplicating a second one, let's say in this direction. So maybe we'll want to have it split in two different directions like this. So we want to get the information from both. But now that we have these points, we actually need to make use of them with the dynamic mesh, which we haven't set up yet. Thankfully, that is relatively easy. All we do is right click and search for create empty, and you'll get create empty dynamic mesh. A dynamic mesh is just a housing basically for your meshes that live inside of it basically. Whatever goes on, whatever all the polygons are doing, they're all within this dynamic mesh. It's an empty one, so it only has the housing. It doesn't have any meshes inside of it actually. So we want to append meshes based on these points. So for that, drag out of the create empty dynamic mesh and search for append meshes from points. And the in points, you would have guessed it, will go for the merge points. Now by default, this does not have any static mesh set up here. And so I'm going to go ahead and grab ourselves just a simple editor sphere. And now with it selected, if I go ahead and press A, you will see here on the left in our preview, there's our mesh. And you can see there it is growing in both sides on the left and on the right. It's going in both directions, exactly how our setup is configured. And if instead I press D, you'll see in our world, there's our actual preview. Now keep in mind that this preview, while it is being updated live, is not actually spawning in the world. This is just a preview of the dynamic mesh. I can just drag in more splines if I want to and have them just line up and connect to different areas of the section. And we'll just get different actual splines here, just all spheres attaching between all of them. So cool. Let's say this is kind of the setup we want. So awesome, we have this. So now what do we do with it? Well, the first thing we want to do is kind of merge it all together. We don't want to have them be separate spheres. We want one mesh for everything. Now, if I drag out of the mesh to points and I search, for example, for solidify, there is no solidify. Even though dynamic mesh has a solidify option, if I search for dynamic mesh here, you can see this is all the options we have. So what we actually need to do is create our own system. Thankfully, that's pretty easy to do. If I right click and search for execute blueprint, and then in the detail panel, if you search for dynamic mesh, you'll see you'll have a couple of options. I put in a few extra letters here because I have things that show up because I've been testing. So this is all pretty much you're going to get. Dynamic mesh simplify and this manual processing one. If you select any one of these, doesn't matter which one, all you care about is the fact that it'll populate it in, and then you can click the browse asset in the content browser, and you can open this location. Because then all we want to do is take this and copy it into our folder. And then we can go ahead and just rename this to dynamic mesh solidify, and then open it. And one thing you'll notice is nothing first, but on the left here under functions, there's only one thing. If you double click it, that is the graph. You can of course make this yourself from scratch by just creating the proper setup, but this makes it easy. It gives you kind of what you want, and what you can notice here is it just has an input with your dynamic mesh. There's no output to be plugged in. Nothing needs to be passed through. It just gets set up, and that's it. The reason I'm just showing you this specifically is it's so easy to use the more custom things of dynamic meshes and make your own setup, which we'll be doing. We'll create a bunch of dynamic mesh nodes that you can just migrate to another project later on, and you'll just have them available to you. So just because you don't see it by default right now inside of PCG as a pre-made node, don't worry, you'll effectively have them for the future. So in our case, I want to go ahead and voxelize the thing, which is a solidify. So I'm going to delete what was there, and I'm going to drag out of this in dynamic mesh and search for solidify, which in our case is our mesh solidify voxel wrap. And I'll plug that into the return node. And if I'd like to, I can go ahead and just search for make here, and I can make the settings if I so wish. I can expose any of these. So if I want to make customizations to how it looks, it'll become very easy. For example, I can just right click on thickened shells, promote to a variable, and then right click on shell thickness, promote that to a variable. And then we no longer need vertex count, so I'll get rid of it and expose the two new variables that I've created. And now with this, I can just replace the one that was here by hitting this arrow with it still selected. And there's our dynamic mesh solidify, and there's our two values. It is that easy to expose them, and if you opened it, you could see we could even use attributes for these if we so wish. So it's literally that easy to set up custom things with dynamic meshes. So now what we could do is just take our meshes from points and plug that in. Now if I press A here, you will see that in our world here, we now have a combined mesh here. Look at that. It might be a little hard to see here, so let's press D instead, and let's look at it in the world. So you can see it is now all combined. We no longer have individual spheres. And here, let me show you what happens when I take the spline sampler and change the distance increment here. So this is currently at 50. If I set it to be 100, you can see it becomes a little bit rougher. If I set it to be something like 30, it becomes a little more smooth. But this is just the basic shape of it. 50 is probably going to be just fine. What I want to do now is, now that we have this shape, I want to UV it, give it some basic UVs, and then I want to displace it just a little bit to give it a little bit of warp. And we'll use custom nodes for that because it's very easy to set up. So I'm going to duplicate this solidify. I'll call this just auto UV instead at the end. And I'll open that up. Again, open the process dynamic mesh. In this case, we'll go ahead and remove these and remove our two variables. So we got the clean setup again. If I drag out of in dynamic mesh now, I can search for auto UV, and I'll get options for X Atlas and patch. In my case, I'll just go ahead and use X Atlas. We can experiment with both. They both come with different options that you can expose, including iterations. I'm going to go with the default X Atlas here. But before I do this, I find that because we did just generate this mesh, I want to first repair mesh degenerate geometry. So if there was any issues with the mesh, I want that fixed. So let's plug that in and then do the UVs. And then once it's created the UVs, I want to make sure I pack them by using a repack mesh UVs node. As you can see, the dynamic mesh just goes to target mesh. Target mesh then gets pushed through, is just a way of setting it all the way through for convenience. I love that they created an in and out for your starting and ending mesh. You can just pipe all the way through. Then you plug it into the return node at the end, and we're doing it all on UV channel 0. And this is really all we need here. I can go ahead and duplicate it, plug it all the way through, and here I can swap it over to the auto UV one. So now we know that this one's going to be automatically UV'd. And if you take a look, you can see the mesh now looks a little bit different in terms of its texture here. If you look here, right, we have the grid here. If I go ahead and sample the one before it instead, you could see you really could not see that texture grid at all. So now we know it is being UV'd. It's not beautiful UVs, but it is being UV'd. From here, let's go ahead and grab us a displacement one. So again, let's duplicate the solidify, rename it to displacement, open it up, open the process dynamic mesh, remove this stuff, remove the variables, and now we can go ahead and set things up here. This one's going to be a little more complicated. It's only just a few nodes. From the in dynamic mesh, I want to first apply some tessellation. So I'm going to search for apply PN tessellation and plug that in. And then we have a tessellation level. I can right click on this and promote to a variable. And this is going to be an exposed variable, so we can control this. Default is 3, which is fine. From here, once it has tessellated, I will like to go ahead and recompute the tangents. So I'm going to search for compute tangents. Because we've recreated this mesh, the tangents on the mesh are kind of a little bit messed up. So I just wanted to recompute them to make sure we got proper tangents. And now we need to do the displacement. So from this target mesh, we can search for displace from texture map. Now this node takes a selection and a texture. Well, the texture we can provide, we can right click on texture and do promote to variable. Now keep that as a variable and expose it. And then if we compile it, we can even give it a default texture. I'll just search for noise and find a random one here. For example, this offset noise distance fields. That's fine. I'm also going to want to expose the options in this case. So I'm going to drag it of options, search for make, and make the options here. So we get the options like magnitude, scale, etc. So I'm going to right click on pretty much all of these. I'm going to promote them all to variables. The only one I'm not going to convert is this empty behavior. I can just leave it as default. That's fine. And I want to make sure that I have exposed all of these new variables that we have now created. Last thing here is the selection. If you want to select part of the mesh, if I hover over it, you will see if non-empty, only the vertices identified by the selection will be subject to the displacement. Otherwise, the options empty behavior will be followed, which is the one here. In our case, it's full mesh selection, which is what we want. So we don't actually need to plug in anything into selection if we don't wish to. And after this, we just go ahead and return. From this auto UV, we can go ahead and duplicate this, plug in our displacement. At this point, you might notice as you're doing things, it's starting to slightly chug for a moment. That's because whenever you do anything, including just, for example, something unrelated like creating points, it will recalculate. So you can see it's chugging on there. It's fine. So every time you do now anything, because it's now going through the solidify and everything else, it is going to slightly chug. My recommendation is to pause the regeneration while working on it until you need to actually go ahead and preview this. This is not designed for live updating. This is designed for you to create something that you can have in your world at the end. But it's not meant for generating at runtime or live in any way. So what I'm going to do is pause regen up here at the top. And now I can go ahead and plug this dynamic mesh auto UV in. It's not even going to realize that it is no longer disabled because something's been plugged into it. But again, that's because pause regen is turned on. And from here, we can customize this. I'll go ahead and up the amount of tessellations. I'll change the magnitude to something like 200. I'll keep the UV scale as is. I'll change the center to be 0, so that way it'll only push out. It won't push out and in. And image channel 0 is fine too. And then I can turn off pause regen. It'll go ahead and regenerate it with this, and you'll see the disabled icon goes away. From here, if I go ahead and press D to debug it into the viewport, actually, you will see there's our tunnel, and maybe 200 is a bit too high, but you can see what's happened here. It's now displaced it quite a bit in all directions. I can go ahead and change that to something like 100. I'll displace it a little bit less. I could recenter it back to 0.5, and then it'll push in and out. But depending on the shape, I found that pushing in sometimes will just cause issues like this. So I personally prefer to just only push outwards. I can also, of course, change the noise that it is using and also tile the noise. And you can see as I'm changing these values, the amount of change here is noticeable. You can see it's now much more rough. I can maybe displace it a little bit less. It depends on how close these tunnels are to each other. But the values I've gone here that you've been looking at is 50 magnitude, 5 and 5 UV scale, 0 center, 0 channel. I'm using a low res blurred noise. So this is pretty good, but one thing you start happening when you actually go ahead and displace it is things start to kind of overlap each other, especially in these areas. And really what I would like to do is re-solidify it, refix up all of these overlapping areas. So if I was to push it out further, let's say to 100, you could see that it starts to overlap these areas even more. So I'm going to re-solidify it by grabbing our solidify here, duplicating it over, and then plugging it at the end here. Again, you might want to pause depending on your system, and we can debug this one. And you'll see there's our now combined nice version, nice and good. It is, of course, lower res again, but that's okay. I don't need it to be higher res for this version. If I go ahead and fly inwards and fly around, you might notice occasionally stuff like this. This piece right here, and this one below it, these two, are just extra little pieces that are just there. They're floating in this world. They're inside of it, and when it was trying to re-solidify, it found that, you know what? It figured these are solid areas that it wants to keep. So we have these small little pieces everywhere. We don't want to keep those. We want to get rid of everything except the main large shape. So as you might have guessed, we can go ahead and duplicate solidify, rename it to remove small pieces, open up the process dynamic mesh, remove all of these as before, and from in dynamic mesh, search for small, and you'll get remove small components, and we can plug that all the way through. And we can just leave it all by default. If needed to, though, you do have a minimum volume area, as well as the minimum triangle count if you so wish. For our case, the default is fine, but if you're putting this in other projects, you might want to expose more things than I'm exposing. For me, these controls are just fine. So again, from here, duplicate it, swap out the input here, and then plug it all the way through, and then go ahead and enable the last one. And then you'll see the two pieces that we had floating here are gone. We only are left with the actual giant mesh in the middle here. But of course, if we're on the inside, we kind of need to see the inside of this mesh. We don't care about seeing it from the outside. And while you can just make it a two-sided material, I would personally prefer invert the normals. So that way it's just facing inwards. It doesn't need to be two-sided if it doesn't need to. So just like before, duplicate, rename to flip normals, open it up, open process dynamic mesh, remove the extra things, drag out from in dynamic mesh, and search for flip normals. And there's our simple flip normals. We just plug all the way through. Nice and simple. That we once again duplicate, plug the new node in, plug it all the way through, and then debug the new node. And you'll see that there we go. We now, from the inside, have our tunnel system. And you can see it goes this way, it goes up as well. And wherever our tunnels are going before, it is now going there as well. So at this point already, we can go ahead and make this area just considerably bigger. And you'll see it'll scale the entire thing. So just go ahead and do cleanup and generate again. And you'll see it's back to the original area. Now, if I want to, I can go ahead and start moving these around and it'll regenerate the entire thing. As you can see, I moved it over there. Now we have a connection here into two different paths. And I don't actually need to have all of these fully connected. I can just take this node and just connect it close enough here where it will just intersect inside of it. And you can see, there we go. We now have a connection here. Because we're rebuilding this setup, we don't need to have these splines all together as one. We can just put in more splines. I can just drag out another spline over here, and you can see it immediately puts it as a new tunnel. While doing this, it might not be a terrible idea to just select your tunnel system and just do a simple cleanup. So that way it's not regenerating it as you kind of lay it out. I mean, you absolutely can. It depends on kind of the system you're doing and how fast you want to make changes to it. But now I can go in here and say, I want a system that kind of loops around and maybe reconnects all the way kind of over here. Then I can go back to my system and click generate, and you'll see that we now have the tunnel system going all the way across and reconnecting here. So this is cool, but at the current moment, not only are we just getting started, we actually haven't spawned anything. This has so far been just previews. So at this point, I want to actually store this as a mesh that I can then use. And thankfully, that's relatively simple. I'm going to stop debugging this, and then I'm going to specifically make sure to click pause regen. Otherwise, what we're about to do from here on out will constantly be saving and overwriting the mesh and regenerating everything, which is going to drive you crazy. So make sure you start using pause, or you could split up the next kind of little bit into its own graph later on. I'll show you and explain that as we get into it, but just know that when you're saving it to the content browser as a mesh, any updates will resave it. So I'm going to right click and search for save dynamic, which will get us the save dynamic mesh to asset. I'll go ahead and plug it all the way through because it's paused. I don't need to worry about it resaving. And then in the detail panel here, I can make some changes. First of all, I don't want to open the save dialog every time. This will ask you where do you want to save every time, and I don't want to do that. In my case, I just want to save it automatically. For the asset name, I'm just call this SM_cave system or static mesh_cave system. The asset path is going to go into /game, and then in my case, PCG. Again, /. This game is your content folder. You don't do content / your folder name. It's game / your folder name. So just keep that in mind. Replace content folder with game, and then it's the same path as you would for anything else. From here, though, you have some copy mesh asset options. For example, we can set up nanite settings. I can turn on nanite for this. I can turn on apply nanite settings, so it goes ahead and enables it. And whatever else I'd like to do here, including setting up a new material. For example, I have a world position material that I've set up for this, which is just a simple use a bunch of world aligned textures. I just grabbed a random rock here. So I can go ahead and plug it into new materials here. I mean, even give it a new material name. Let's say cave walls. Then when I go ahead and click pause region again to unpause it, or Alt-R is the hotkey, it'll go ahead and run through everything, and it'll go ahead and save it. And if you take a look, there's a static mesh right there. If I go and open it up, you'll notice, well, everything seems correct except one little detail. The material. The material is not only not assigned, we have 0 material slots. If I go ahead and add a material slot, and then I can overwrite it here. But this is not going to overwrite it actually in the level. If I make a change to it, let's say I take this point and just move it over to the right instead, it'll regenerate everything. But you'll notice that here, it's still facing the original direction. Well, why is that? Well, for some reason, you have to go back to your PCG graph and click cleanup and generate and reopen the static mesh. And here again, we have no materials. So you can't just like set the material and then just have it override the file without updating the material. But there is a workaround. It's a weird workaround, but there's a workaround to allow you to assign the material you want. Inside your full graph, I'm going to go ahead and pause the region again. And what we're going to do is instead of using just a create empty dynamic mesh, we're going to use a mesh, assign a material to it that we want to use, and then we're going to remove the mesh from our system. So all that's left is the memory of the material effectively, and not the actual mesh. It's really odd. There's no set material options within the actual full system here. There is a way of setting a material inside of actual geometry scripting, but that involves using the actual geometry script component, which we do not have here. So we can't really just assign a material. So what we're going to do is right click and search for static mesh to dynamic mesh element. Here it can be whatever it is. For example, we can just use this first cube. It doesn't matter what it is. We're interested in this override materials. We go ahead and press plus here and plug in our world aligned material in here. So whatever material it had does not matter. You don't have to use this override materials. If you have meshes with the materials already applied, you can go ahead and use them. You can even have them be exposed. You would not be able to expose the override materials. So if you want to swap materials easily, you would technically need to assign them to the static meshes and then swap static meshes. Hopefully in a future version, this will not be needed. But once we have this, we need to make it go away basically. So from here, I can search for dynamic mesh transform, and I'm going to scale this to 0 all axes. So it effectively has disappeared. At this point, we don't really need to do much except just swap this out. So if I just drag it all the way through, we can use this as our original seed instead of U. Technically speaking, there is a sphere of a size 0 here. If I go ahead and unpause the generation, and if I reopen this cave system, you'll see that we have the original material that we applied there and a world grid material. Now this grid material, we can just delete material slot because it's not really assigned to anything. The whole thing here is the rock, as you can see. So where's the second one coming from? It could be from here, which is in the detail panel of the save dynamic mesh asset node. We did create this, but that's not where the second one is. In fact, we can just go ahead and delete these. We no longer need them because we saw that they didn't do anything. It's actually coming from this append meshes from points node, because in here we have this static mesh that it's appending from, and it is now actually getting the materials because we have extract materials turned on. And if I go ahead and turn it off and recomputes everything, you will see there's our original just cave material. Now you might be thinking, well, hold on, this had extract materials. Why didn't we get the material from this editor sphere when we did our append and everything originally? You and me both. I am also wondering this question. I don't know why, but this is a solution. You just have to create a mesh, scale it to nothing, and then use that. And the reason why it's fine in our scenario is because we're going ahead and removing small pieces. So it's perfect. But at this point, we have an actual cave system that we have as a mesh. So at this point, you can start setting up a second graph that now utilizes this, or you could put it all in the same graph. The positives of putting it into the same graph is when you're dynamically changing the actual cave system dynamically, you get to see it with all the props you're spawning and everything else right away. The downside is it will take a little bit longer to compute every time you do make a change. Depending on how you want to set it up, you might want to lock in the mesh, which is the entire cave system, and then populate it, or you can do both together. Entirely up to you. I'll be showing you how to put it all together because I feel like that is the more complicated of the two, so we'll do that. After the save dynamic mesh asset, I want to make a note of what this asset path and what it's actually saved. So I'm going to drag out of here, as for named, and I'm going to add a named reroute declaration node. Then I'm going to press F2 to rename it and call this saved mesh. And then we need to actually spawn it in the world. So what I'm going to do is right click, search for get actor data. We want a regular actor data. Actor field will be self. The mode will be get single point because we just want to know where the actual actor is in the world. And under advanced here, make sure to turn on execution dependency required. And I'm going to open it up and expose this execution dependency and plug this saved mesh into the execution dependency. Then I'll close it up. And now we have the get actor data that is going to wait for the things before it to finish before it does this. So from this get actor data, we now have the position of the actual bounds that we plugged in, but we need to actually store the saved mesh on it. So I'm going to drag out of here for add attribute. We want the parameter version, and I'm going to grab saved mesh. So I'm going to right click, search for saved mesh, and plug that into our attributes. And in the add attributes, I will just rename the target here to be mesh. So now we have the attributes added to this point information of the original mesh that we just saved. The other thing I'm going to do is drag out and search for apply scale to bounds. The reason I'm going to do this is because our actual volume here is scaled. You can see it's scaled to 100, 140, and I don't want the scale applied to the mesh we're spawning. So instead, these values are going to just go into the bounds instead of the actual scale. I could also use a transform points and set to absolute scale of 1. There's a few different ways of doing this. But after this, all we need to do is use a static mesh spawner, swap the mesh selector type to by attribute, the top option, and the attribute name will be mesh, which is what we just made here. And then when we unpause the regen, it is going to go ahead and spawn the actual cave system. It's actually spawning the mesh. And if we want to, we can now go ahead, take this tunnel, rotate it, it'll go ahead and regenerate it. And then you would think it would regenerate with it actually in the world, but no, for some reason, it is no longer actually updating it. As you can see, it's regenerating it, but then nothing shows up. For whatever reason, when using this method, I have to do cleanup and generate manually in the graph. And when I do that version, no issues. There's our new extension that we just made. Force regen up here will not do it. Updating the graph will not do it. Specifically, cleanup and regenerate will have it work. So this is why you might also want to think about splitting into two graphs instead of having it done in one. So one just creates the actual setup and the other one uses the setup afterwards. Otherwise, just know you have to do cleanup and generate from whenever you want to visualize the change. I wish I could give you an answer. If someone knows, please let me know in the comments below. But now that we have the static mesh actually spawned, we can go ahead and populate the stalagmites and stalactites on it, which is actually relatively simple. From here, I'm going to pause the region while I work on this. I'm going to right click and search for a mesh sampler, and I'm going to open it up, and I'm going to need a static mesh input, which we can use the saved mesh that we did before and plug that all the way through. And that mesh sampler, again, is going to have the dependency of the static mesh spawner here. That's going to be plugged in, and then we can close it up. I'm actually not going to tweak any of the values on here. I think it's fine by default, but just know there's a lot of different ways of sampling this. The 1 point per triangle for me works because it is relatively low res. You can also use Poisson sampling if you wish. It depends on you have more or less dense mesh and how you want to sample it. And our advanced, make sure to turn on execution dependency required. But at this point, if I go ahead and press D on this mesh sampler, I unpause it, you will see we have a lot of little points here. They're quite small, but they are there. They're all over this mesh. To make it easier to see though, I could just add a bounds modifier here and set the scale of the bounds to be 10 for all of these minimum and maximums. And you can see here, there's all our points. And if I zoom out, there's all our points around the entire mesh. So like I said, for me, this is dense enough, so I don't need to change all the settings. But now we need to filter out the floors and the ceilings so we can put in stalagmites and stalactites. Both are going to kind of operate the same way, just with slightly different values. So we'll go with the ground first. I'm going to search for normal to get normal to density. And if I go ahead and debug normal to density, you'll see all the points near the bottom are actually white and the ones near the top are dark. Now, you might normally expect that by default, with the value set to normal of the positive y, it should go top to bottom. But because we've inverted the normals, this is now the result. So the bottom becomes positive in the z-axis, because that is the one facing up. So now that we know this is the floor, we can just use a simple density filter. I'll filter out most of the angle by setting this to 0.95. So almost the ones just at the bottom there will be grabbed here. Then from here, I'll use a select points node to filter out a random amount of points. In my case, I want to keep 75%, so I'll put it to 0.75. And then I want to randomize what I'm going to spawn on there. So I'm going to use a transform points node. I'm going to scale everything from 0.2 to 0.5. I'm going to give it 360 degrees of rotation on the z-axis. And I'm going to give -5 to 5 on the x and the y axis for rotation. The position can stay where it is. That is fine. You can absolutely add offsets and tweak these values for your own needs. And from here, we can spawn whatever we want. So I'll use a static mesh spawner. In this case, I'm not going to use an attribute. I will just use some mesh entries. So I'll go ahead and populate this one with a PCG boulder 2 here. I'll just go ahead and overwrite the material to be the World of Light material that we've been using. And to simulate stalactites, I'll add one more mesh in here. And this is just going to use a simple default cone that, again, I will override the materials on and plug that in. And you'll see there's our rocks, there's our cones, and every so often you get a few here just at the bottoms. We can have it go up higher on the sides. If we change the density filter to, let's say, 0.9, you'll see it goes a little bit further on the side. So it depends on what you want. So this is the bottom. So I'll just go ahead and call it that. And then I will take the entire thing, duplicate it up above. The difference is on this duplicate on the normal to density, instead of +1 for the normal, I'll do -1. On the density filter, I'll change this to like 0.6 so we get more of the ceiling actually doing something. On the select points, I will keep far less though, maybe 30% by setting the ratio to 0.3. And on the transform points, change the rotation on X to +175 to +185. So it's plus or minus 5 degrees once flipped 180 degrees. The rest are fine. For the scale, I want to change things as well. I'm going to turn off uniform scale. I'm going to have it scale from 0.2, 0.21 to 112. So that way it's vertically much taller than it is wide. And I'll give a slightly better variation here. And one thing I almost forgot to do, turn on absolute rotation for the ones at the top. I don't want them facing inwards. I want them facing pretty much almost exclusively downwards. So these are the values that I like. I'll also rename this bottom now to top and plug the bounds modifier inside. I'll go ahead and recalculate everything. And you'll see we now have things at the top. But you can see the rocks are also up here and we don't want them. So in a static mesh spawner, because we did duplicate everything, I'll just go ahead and delete the input one here and leave just the cone. And now you can see we just have the cones up top, which looks pretty nice. Now we are seeing the light all the way through because we do have a full directional lights here. So let's go ahead and tweak the lighting to make this much nicer. I'm going to change the directional light intensity here to something very low, like 0.01. So it's almost pitch black. And then I'm going to hold L and left click to add a light. And now I can put in a few lights here and there to kind of get our way around this place. And you can light it as you see fit. Now it's still a bit bad, so I'm going to just add a post process volume here. I'm going to search for unbounded to turn on unbound. And under exposure here, I'm going to turn the metering mode to manual and set the exposure here 10. And now I can go ahead and increase the intensity of these lights. And we can get nice moody lighting in here, however we'd like. So we have nice darker areas and lighter areas. So this is pretty nice. The one other thing I want to show you guys, which is probably very important for you guys, is how do you make a hole in this thing? Because it's cool that we have a cave system, but it's a closed off cave system. There's no holes here to get into it. And ideally, it would create the hole with the entire system, and so that way it doesn't actually spawn any stalagmites, stalactites, or rocks, or whatever you're spawning in there. It won't work with it. So how do we do that? Thankfully, relatively easy. It just needs a few extra nodes and a few things to cut things out with. So what I'm going to do is add ourselves a simple sphere in the world. It's just going to be a regular geometry sphere. All I'm going to do is go to the detail panel, search for tag, add a tag called hole. And then I'm going to come here and position it where I want this hole to be. So let's say I want my entrance here, and I'll go ahead and scale it up, where if it cuts it out, it will have a nice large entryway right over here. That seems like a good spot for me. The only other thing I'm going to change on the sphere is search for hidden to make it actor hidden in game, and search for collision. Instead of collision presets default, I'm going to say no collision. So that way we're just using it to cut something out here. Then in our graph, we're going to plug something in right before this flipped normals. So I'm going to take all of this and scoosh it to the side, but of course I'm going to pause the region before I do this. I'm going to right click and search for create empty dynamic mesh. In this case, we don't care about the material, so this is perfect for us. And like we did before, we're going to append something. So in this case, we're going to append meshes from points, and the static mesh I want to get from the world. So this setup is going to work with a singular type of static mesh. So if you want to cut out 20 things, you can. You'll just need all 20 things to have the same mesh. You can absolutely create a loop to loop on your meshes, but this will show you how to grab the meshes that you have, and then you can go ahead and filter by mesh, whatever else. In my case, I'm doing a simple version of single mesh, multiple points if you wish. So to get the mesh from our static mesh, we're going to right click, get actor property. We want to do all world actors by tag whole, and you want to make sure select multiple is not turned on, because again, we want to make sure it's only grabbed to one, or this will not work without a loop. And the property name is going to be static mesh component dot static mesh, and that is going to go into the static mesh. And if you unpause region, you know you've typed it in correctly, because if you make any typos with pause region off, it will complain about it not existing. So as long as you have pause region off and you typed it in correctly, you will see no errors. I'll go ahead and repause the region for me. The only other thing we need to know though is the positions of these points. So we're going to right click, search for get actor data. It's going to be all world actors by tag whole. In this case, we want to select multiple, and we also want to change the mode here to get single point and merge the simple data. And this is going to go into the endpoints here. So it's going to append the mesh that we have, which in our case is this sphere, at every location that it exists. I'll even copy it over here, so it'll make a nice opening up top. But once you have this, we just need a simple Boolean operation between here. So I'm going to search for Boolean operation, plug that in between, plug this into NB. And the Boolean operation we want to use is trim inside. And very importantly, under Boolean operation options, we want to turn off these checkboxes. We don't want to fill the holes. We're actually making holes. And I want to turn off simplify output as well. Don't simplify anything, just make a hole. Now you're not going to see any changes here. That's because, like before, select the tunnel system, click cleanup, click generate, and just like that, there's a hole. And we have a hole up here as well. It is actually now following the shapes that we want, set up by the splines, and we have holes wherever we wish in the configuration we want. And because this was set up with splines, you could still sample the splines to spawn things along them, lights or whatever else, or you can sample the mesh itself as you've seen, so it becomes very, very versatile. This is of course not the end-all be-all way of creating a cave system, and this one is not meant for dynamic and live modifications. It is one where you set it up and then you just use it in your game. If you want something more dynamic and real-time, you need to look into voxels. Unfortunately, that is not kind of built into Unreal, and there's no good free version of voxels that I found. But if you have a suggestion for a free voxel plugin that you really like, let me know in the comments below. Other than that, the project files for this will be available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. And if you'd like to join our community, the link to the Discord will be down below as always. And if you're looking for more awesome PCG tutorials, check out this one right over here, which is one of my 5.6 favorites.